Welcome to the SMB3 POSIX Extensions Phase 2 talk. We're going to talk about what we've accomplished and what's next. I'm Steve French I work on the Samba team, and I also work for Microsoft working on Azure storage. The typical legal reminder, these views don't necessarily reflect the views of my employer. So who am I? I'm Steve French. I'm the author and maintainer of the Linux VFS client, SMB3.1.1 client, used to access the cloud, the largest server in the world, Azure, as well as Samba, Windows, all kinds of appliances, various NAS devices. SMB3 seems to be everywhere, on Macs and on embedded devices, and on the smallest and the largest servers. I'm a member of the Samba team. I'm the co-author with Jeremy Allison of the and others of the SNEA CIFS technical reference and former SNEA CIFS working group chair. I'm a principal software engineer working on Azure storage with Microsoft, focusing on the Linux client. So I want to talk today about a number of things. One important thing is I want to remind you guys that Linux is a lot more than POSIX. Some of you may have familiarity with POSIX from friends who worked on committees many years ago. But Linux is an interesting challenge. It's something that I find fascinating. And I also want to talk about why these extensions matter and the implementation status and some details, what you'll expect to see in the future, and how we're going to handle Linux continuing to extend all these APIs. And I also want to touch on Wireshark and some of the good work Aurelian, Ronnie, and others have done with improving Wireshark and our ability to trace these so you can improve your workloads, debug your servers and clients, and make progress in our goals here, which is to make Linux access to the smallest and the largest devices even better over the network. So many of you are familiar with the POSIX API, and many of you are not as familiar with the fact that Linux has this enormous number of syscalls. When I looked earlier in the year, there were over 850 of them. So some of the comments people had, well, we're really, you don't use them, they don't have man pages. Well, I looked up man pages, and actually more than 500 of them have man pages. So you could also argue, well, these are all for specialized devices and they don't apply to the file system. Interestingly, though, that's not true. The file system has 223 of them. That's huge. Now think about POSIX. It had about 100 calls defined in the original standard. So Linux is evolving constantly. Linux is not POSIX. It's not the same as other Unix. Applications often take advantage of these specialized calls, and we have to be able to adapt to those. Now here's a sample of some of the man pages for various syscalls with man pages. It's a lot. Now, you could also argue, well, these were changes made many years ago. Unfortunately, that's not true. Now, last year at SDC, I talked about the 15 syscalls that were added to Linux. And some of these we're having to adapt to. Some of these are just changes to the module itself, not the protocol. But some of these actually are going to require changes to the protocol to do well. Now, last year of the 15, IOU ring was a large subset of those that was added in the 5.1 kernel. So this is the year before last. And then various things that Dave Howells and others did, FS mount, move mount, these kinds of things, FS config. These calls were added in the 5.2 kernel. Now, you could say, well, what about last year? Well, last year we only added 3, but that's still a lot, right? OpenAT 2, FS access 2, OpenAT 2 in the 5.6 kernel, FS access at 2 in the 5.8 kernel, and most recently, close range. Now, what does this mean for us at network protocol? It means that we have to be able to adapt both the module to, we can't be like Lustre and be out of the kernel and be able to easily adapt to these changes. It's really down to a couple network file systems, NFS and SMB, and we have to be able to adapt both the module as well as the protocol as these APIs extend. Many of these APIs are driven by local file system activity, but we have to be able to handle them in the network file system. And as you might guess, the XFS developers and ext4 developers sometimes, but don't always, check with the SMB and NFS developers before adding these. And so in many cases, these features lag on network file systems for more than 10 years. And that's not a good thing. And what we don't want to do is have to be way down in the standards committee where it takes 5 or 6, 7 years, 8 years to make the changes we need to implement a feature that a Linux application needs. Well, you could argue, well, why do we care about this then? Why do we just give up on network file systems and use blobs, use network block devices? Why can't we do everything with NVMe over RDMA, right? Why do we care about network file systems? And the answer is very obvious, right? That block devices struggle with tasks that file systems find very easy. Locking, security, leases. These are important things. These are very, very important things. If you think about metadata, keeping metadata consistent when multiple people are accessing the same data, only really a file system can do that well. It was an interesting argument a year and a half ago at the File System Summit. You had some block device developers arguing about an RDMA case where network blocks device was causing significant problem because it had pages locked, and it ended up causing very serious problem when two clients were accessing the same device. The file system developers on the other half of the room were looking at the block developers like, what's the problem? Use a file system. But the network block developers, people thinking about NVMe over RDMA and this sort of thing, don't often think about how this could integrate under a file system, under a network file system. So it's very important. Network file systems are designed for this, to allow multiple clients to safely, securely access data without corrupting it, implementing locking, leases, delegations, keeping metadata consistent, being able to use the ownership information, the information about the currently running process, to be able to optimize the I/O pattern, to be able to handle security and access control well. These are things that that only network file systems can do. And so it's important that we be able to do this as we go forward. Linux apps continue to need to work over network mounts. Now, in 1984, there was NFS, the birth of NFS and the birth of SMB. I remember talking to Barry Feigenbaum about this many years ago, the inventor of the SMB protocol. And it's interesting, fast forward more than 30 years, and many network file systems have come and gone, and we're still left with NFS and SMB, just newer dialects. And they've improved in many, many ways. But we have to make sure that all these extensions that we're talking about to make Linux work well, and we've done this before, by the way, we did Linux extensions for the SMB1 protocol. And the Mac developers have done extensions for the Mac that they currently use, that are implemented in Samba and the Macs and other servers. So it's very important that we improve these situations where customers have Linux clients and make sure that these extensions work with the most optimal, newest SMB3.1.1 dialect, not the less secure SIFS dialect. And we don't want to encourage SMB1 at all. So let's make sure that these extensions work well. Well, what works now? In the 5.1 kernel, you can actually try these. You can enable them with mount option POSIX. The 5.8 kernel added the last remaining piece on the client, although we still have a few bugs to fix. We added the new POSIX info level. You can do query FS info, in other words, statfs. You can do query info stat, POSIX locking, Modebits, ownership. You get POSIX semantics and on link and rename, advisory locking, the OFD style advisory locking that Linux uses. So all the major features work, although we do have a bug we're working on in reporting ownership in stat. And that's on the client side. But what about the server side? On the Samba server, there's an experimental tree. Jeremy Allison has it. It's visible on git.samba.org. The master SMB2 branch has it. All the major features work. The merge for that's been delayed due to some time-consuming conflicts, which you've probably heard about before. Some very large changes being made to the Samba file server, including relating to some of the things that we saw in the previous slides. The special file handling of sockets, FIFOs, and care device handling needs a minor update in Samba. But all the major features work in that tree, and it's expected to be merged into Samba as the other merge conflict gets resolved with these larger changes I mentioned. Interestingly, Samba also has added support for client tools. So we now have two clients. SMB client is sort of an FTP-like tool that allows access to SMB servers interactively at the command line. It's all user space. So thanks to work by Volker Landecki, we have major features of that work with the POSIX extensions. We can add additional options as needed to the command set that SMB client supports in user space. So we have two clients. We also have a third client in a way. We have a Pike sample code that Aurelian at SUSE has written. So we have three client implementations to try. We have the Samba server. We also have the beginning of the POSIX extensions in Namjae's SMB3 kernel server, sysd or ksmbd.ko if you want to know the module name. It's partially implemented. It negotiates the POSIX context and partially parses the POSIX open context, but it's not fully implemented yet. Something we'll need to work with those developers on over the next few months. And at the last two SNEA test events, we got a chance to test with third-party implementers who've also prototyped the POSIX extension. And as we'll talk about later in the presentation, we also have Wireshark patches available. So you can do network analysis of this. Aurelian has a tree for that with a link later in the presentation. So this is pretty good progress in the status. But one of the things we have to think about is where are we going to go from here? It's an interesting question. Now, let's first briefly summarize the POSIX extensions. The goal was to make them as simple as possible. And since SMB3.1.1 is the richest network protocol or family of protocols, if you want to include all of the things around it, like the witness protocol and things like the DFS protocol and the various DCRPC things that go along with SMB, if you want to include all of this, it's the richest network file system protocol by a lot with many, many features. So in many cases, we can emulate things rather than having to reinvent the wheel. So we tried to make this as small as possible, but the first thing that has to happen at negotiate time is that we get the server to agree that it actually supports the POSIX extensions. And here you can see the Wireshark trace where the client is indicating by sending these POSIX extensions here that it supports a particular version of the POSIX extensions. Now you can see the POSIX reserved context there with the version number, the sort of a UUID for which version we support. And here's a little more detail on that. The server then responds with that POSIX context if in negotiate protocol, if the server supports it. Now, if the server responds in negotiate protocol that it supports these extensions, then the client has the choice of sending on create the create context that we talked about earlier. You can see the tag here in the POSIX create context. You can also see that in the POSIX create context, we can now send the mode. So here we're sending the permissions of 760. Anyway, so it's nice to see that we've got these POSIX extensions and they're small. Negotiate protocol indicates whether we support it or not. Create, if we choose to have POSIX semantics on that file handle, we send the POSIX context on create. Now there's additional info level. So here's the POSIX create context, a little more detail. There's an additional info level that allows us to query POSIX information more efficiently rather than having to do multiple calls. And this info level is really one of the very, very few changes that we had to make to the protocol. The behavior of the files that are open changes, if you're unlinking or renaming based on that POSIX context, but the actual number of new levels is small, one for query info, one for query FS info. Now I mentioned earlier that Volker had done experimental support. Volker had done support for SMB client to have to be able to use the POSIX extensions, and you can see an example here doing POSIX_makedir with the mode, so you can specify the mode on makedir. It's nice to see we now have a this gives multiple clients for us to test with for the POSIX extensions. So a couple of days ago, I did an example. I opened, so one of the things that's important is that delete and rename semantics match what POSIX or Linux expects, not what Windows and SMB would typically default to. When you try to delete an open file, usually it fails in Windows. Here, what we see in POSIX is exactly in SMB with the POSIX extensions is what you'd expect in POSIX. We open a file in the first window here and keep it open, file 0777, and then we delete the file over the network mount, and then we do an ls of the directory, and you can see that it's gone from the namespace. There is no file 0777 in that directory. Now, the good news is that this is exactly what POSIX expects. And in the past, without the POSIX extensions, what we would do in SMB is we would do the delete, just this, in the RM, we'd open the file, set delete on close, and close it. And then when that tail command in the window above exited, then the file would disappear from the namespace. But the difference you'd see without the POSIX extensions is that in this example, when you try to remove the file, it would work, that's true, but the ls command would still show it in the directory mount 2 until the tail command above exited. So with the POSIX extensions, you get much better POSIX semantics. We try to emulate the best we can before, and in some ways better than NFS, right? NFS has the silly rename concept, right, where they can rename the file to, dot something or other, so you don't see it quite the same way when you remove it. That's a little different than what we're talking about here. So I think that this is actually, a good example of the small, modest changes we made can have significant impact on the applications. Also, of course, when you specify the POSIX context, you get case sensitivity. So another example here that I thought would be helpful to see is the Modebits. You can see various files with different Modebits, and they match what they are on the local file system. As I noted earlier, the ownership, unfortunately, is wrong, and you can see that here the file is SM-French. It's reported correctly by the server, but there's a client bug that we're fixing now on that. But the Modebits are reported properly and created properly when you create a file directory. And as I noted, stat returns the correct information, except we have a partial problem with ownership here that we're fixing. And that's a client problem, not a server problem. So significant progress on the implementations. But now let's talk a little bit about why do we talk about SMB3 or SMB3.1.1 for this? Why wouldn't we just invent some new file system? Well, the answer is because file systems are hard and reusing code helps. We can look at the example of Lustre and it getting removed from the kernel. We really need it to be lots of eyes on it and lots of regular, boring changes. Kernel development's hard. Now, there are more than 60 Linux file systems, but only 6 drive about 75% or more of the activity, including the VFS layer itself. That's BTRFS, XFS, NFS, and CIFS. Looking at this last year, BTRFS most active, then XFS, then CIFS, then NFS, right? These are extremely, many people look at these. And it's important to be able to get those eyes on it. In addition, the SMB protocol is by far the most functional, broadest. It has so many optional features that it really does become useful. And it's implemented most broadly, of course, everything from Macs default to it to Windows, Samba, lots of embedded devices. But I think what I like best is that this family of protocols has the most exhaustive set of documentation, and the documentation had to be supported by test cases, many implementations. So, the documentation is enormous, and it's being kept up to date as we find, errors and little notes that have to be made about implementations. It's incredibly helpful. No one person could remember all this documentation. And it's easy to find and easy to use. But in addition, the test cases prove the documentation correct, or if they found bugs in the documentation is corrected. The other thing that's been interesting about that is that it's allowed developers like the Samba team to implement their own test cases, separate from those that were used to prove the documentation. And Samba's SMB torture test suite is actually larger than most network file system servers. It's a couple 100,000 lines of code. So it's interesting how big the test cases are, and that doesn't even include the test cases for Python SMB and for Pike and things like that. But SMB torture is amazing, and then of course there's all these open source Microsoft test cases as well, and lots of stuff at test events that we're having a test event co-located with this event. SMB has a regular pattern of multiple test events a year, so this is incredibly helpful. And another argument why we run the POSIX extension, because it's been done before. We know it's doable. It was almost 30, actually more than 30 years ago. SCO, HP, and others did POSIX extensions, Unix extensions to SMB1, and they were documented by SNEA for SMB about 20 years ago. Now, why not other protocols? Well, because SMB3.1.1 is very easy to extend. It already works with more of this broad set of protocols. It has the most exhaustive set of test cases. It has more documentation than any of their protocols. It's proven across a wider variety of client types, operating systems, and architectures. And let's not forget, Samba is amazing. 3.5 million lines of code. It's incredible. But we have to deal with the Linux kernel, and the API is changing every year. New flags and these new syscalls I've been talking about. And we need to be able to quickly update the protocol. We need to move a little faster here, and we need better interaction with these key communities like containers and databases who may not know how to spell SMB. They may not know anything about SMB, to make sure that their requirements are embedded in their protocol and their performance issues and performance requirements are included. Any functional requirements are included as well. And if they want something that can't be emulated, we need to extend the protocol. So what's the next step? The next step is we have to examine every single xfstest skip and failure in much more detail. And some of that has typically goes on at these test events, but this work has begun. In addition, we have to set up we have this thing called the build bot that runs automated test cases against various test targets from Azure to Samba to Windows, and now the kernel server. But we also have to run this against the POSIX Samba tree and make sure we don't have any regressions. Like I said earlier, we had this issue with ownership being reported wrong in stat. And part of the reason for that is that we're not automating yet. We need to be doing that next few months, automating the testing of the Linux client against Samba with POSIX. But for the next step, we also have to examine every single current skip and failure, because xfstest is kind of the de facto standard for testing Linux file systems, whether that's ext4 or XFS. Obviously, it came from the XFS developers, but it has nothing particularly to do with XFS now. It's very, very broad. It's used for testing SMB. It's used for testing any file system on Linux. And it's over 600 test cases now. And we've also added some CIF-specific test cases as well. Now, this is the standard functional test suite. No one file system can pass all of them. There are various file system optional features, and about half of these are not passable for a network file system because they rely on creating a block device locally or some such. Now, many of these can already be emulated, but we just need to do more work. For example, we could emulate temp file requirements on many test cases, create temp files. There are some ways we could trick the system into letting us create a temp file already. But some of these will need new flags in the protocol, or they'll need new features in the protocol. And where that's not possible, we may need to add a new POSIX extension version. Maybe add a new UUID. Right now we send one in the POSIX negotiate context indicating we support a particular version of the protocol, but we could extend this in the future. Now let's talk about some examples of things we found in investigating xfstest and what could be added to the protocol or what we might need to consider. Now some of these, there may be ways to emulate. In some cases, we may not have to create a new dialect. In many of these, we may just be able to add in new file system control or a new info level. But let's talk about a few of these. Add support for rename at2. So that's syscall, and now has test cases that go with it. And those are skipped currently because the SMB file system doesn't advertise support. Another example is rename exchange, where you're switching swapping file A and file B for each other. We need to be able to support that for some test cases. Now, there's a lot of contention about POSIX ACLs, whether we should support POSIX ACLs, because as you probably know, rich ACLs, which are based on the SMB model of ACLs, were adopted by NFS in NFS 4 and 4.1. And rich ACLs have been proposed for Linux for many years and have run into some various problems, some political. POSIX ACLs are much simpler. They're really not a POSIX standard. They were a draft that Linux decided to emulate, or to implement, in some of the local file systems. POSIX ACLs don't support deny ACEs, and they're much more primitive than the ACLs that NFS and SMB use that collectively are called rich ACLs. But there are test cases for these, and these, we could emulate them, but there'll be some pushback if we try to implement them natively. They are implemented natively in the SMB1 POSIX extensions. They are implemented in the NFS version 3. But the move in the last 15 years has been toward rich ACLs. So there's some interesting discussion about whether we should emulate them or support them natively in the protocol, even though local file systems in Linux do support POSIX ACLs, many of them. Okay, what else? Supporting chattr flags. You could emulate immutable. You can make it a read-only file, for example, but is that good enough? And how would we support chattr no time? There are lots of flags for fallocate. One of the things in fallocate that's a little bit harder to do safely is collapse range, where you have a file with 3 pieces and you remove the piece in the middle and the 2 other pieces shrink, collapse. So you may have a file that has, 2,000 byte chunks, and in between the 1,000 byte chunks is a 500 byte chunk. You remove the 500 byte chunk and it goes from a file that's 2,500 bytes to 2,000 bytes. That collapse range, where you remove the range in the middle and push the final range of the file down, can be emulated, but it's not as safe. So should we add an FSATL to support that? Because Linux supports that, but Windows does not, and SMB does not. What about adding support for dedupe or defragmentation? These may require VFS changes as well. Similarly, support for otemp file is emulatable today, but to do it right would require a VFS change. The concept of a temp file is used in a lot of test cases. You open the temp file, create the temp file, and then write to it, do your operations on it, and then when you close it, the file goes away. It's perfect for a lot of test cases. And this can be done with delete on close in SMB. And there is a temp file flag already. But the problem with that is that would require that when the temp file is created, that it is opened. And right now in Linux, they open and create the temp file and then close it, and then open the temp file to use it, which obviously doesn't work for SMB, because that act of creating the temp file opens it, it gets closed, then it goes away. And then it tries to open it and the file's gone. So obviously we need something like a open create temp file, a minor VFS change, or we have to emulate it by deferring close for the special case of temp files. And that should work as well, but it's better if we had a VFS change. We talked earlier about rich ACL support. There are 9 xfstest that depend on rich ACL support. We could support that just as NFS can. What about trim support? What about quota support? Quota support should be emulatable already. It's a little different with UIDs and globally unique identifiers that NFS and SMB use. So quota support in SMB obviously relies on SIDs, universally unique identifiers for users, where quota support on Linux uses these small POSIX UIDs. But it is possible for us to emulate that. What about support for NFS export? That would require being able to open a file by inode number, which in effect you can do locally on Windows, but not over the SMB protocol. That might be a change that would be minor, small enough. What about support for case-sensitive XAdders in SMB extended attributes, or EAs, are case-sensitive or case-insensitive, excuse me. There are a few XFS tests that require support for case-sensitive XAdders. What about support for SE Linux? NFS has done a little bit of work to try to propose extensions to better support SE Linux, and that could be helpful for SMB as well. Here's some final examples, and there are others that you may be able to find as well, and please let us know. Test 492 requires support for something called label manipulation. Some of the XFS tests require support for case folding. And another thing I was thinking about is that currently we emulate, last year we added support for this, we emulate the BSD style file locks, whole file locks instead of byte range locks. So NFS and SMB emulate these, but with native support for it, where you actually had a call to send over the wire that supports the BSD style whole file locks, would that help some test cases? So these are examples of things that we dug up running through xfstest and having some discussions with other developers. But as you can see, most of the key features are already either implemented or emulatable. So this is relatively small, but we do need to dig very carefully into this, especially for workloads like containers and some of the database workloads, to make sure that we're doing this efficiently and handling all of their application requirements. Because in many cases, all of their testing initially had been done on local file systems, and we need to be able to run them on network file systems. It is ironic, you can run a local file system on a network file system, right? You can do an SMB mount and do a loopback mount of ext4 or XFS files that are formatted on an SMB mount. But the goal of all this is to allow many users safely to be able to access all around the world that same set of data. And to do that, we may have additional extensions we want to consider. But the first thing we have to do is get the quality improved. Now, as we've talked about before, over the last 3 years, last 2.5 years, we've really focused on xfstest and the build bot. So starting 2 years ago, Ronnie, Aurelian, Paolo, they created this automated testing infrastructure that has helped reduce regressions a lot in SMB. We now pass more than 150. Even without the POSIX extensions, I think we pass more than NFS now. The vast majority are skipped due to missing features or things that are only appropriate for local file systems. Now, many potential issues pointed out by static analysis are also being addressed, which has been fantastic. And we see these coming every few weeks. We see things being posted to the mailing list pointed out by static analysis. It is kind of amazing what some of these tools can find. Now, we have a build bot target for Jeremy Allison's POSIX extensions Samba tree, but we need to automate using that. Right now, it isn't being taken advantage of enough. And we have this regression I mentioned to fix in the ownership on stat with the POSIX extensions, and we need to continue expanding that test list. So the focus over the next 6 months, a lot of it's going to be on this quality, on getting the automation of the XFS tests running, every week to the Samba POSIX extensions tree. And it'll also be focused on helping the server developers out, making progress on the kernel servers, implementation of the POSIX extensions, and making sure that Jeremy and Volker and Metz have all they need to merge Jeremy Allison's Samba POSIX extensions tree into mainline Samba. And of course, at this test event, we're going to continue to work with any third-party developers working on clients or servers. And of course, now that we have 3 separate clients to test, this is a lot easier. Now, for tracing this, Wireshark dissectors have been posted by Aurelian, so you can see that. And I think the goal, I talked to Aurelian and Ronnie, they think that before the end of the year, that should be able to be merged into mainline Wireshark. There's also Pike sample test code that Aurelian put together, thank you, which can help with development of some of the servers as well. Now, what are the next steps? We have to continue debugging these test implementations. So sys.ko, that's in mainline. You can do a lot of stuff. I think that you'll see quite a few of these tests passing in the 5.9 and 5.10 kernels. Jeremy Allison's Samba POSIX test branch, we need to keep improving that. But the current focus, like fixing that stat command we talked about, where it's reporting incorrect ownership, even though the server's sending it correctly, that's something I'm looking at today. So we need to continue to add xfstest to this JRA POSIX test group, so we have a baseline of the tests we expect to pass, and to allow us to regression test the client against Samba server. And then also it'll make it easier for the distros when they backport this to be able to have an objective list of what they expect to pass. We also need a second server comparison point that's easy to view. KSMBD, sorry about the spelling mistake there. We need to extend KSMBD to support the POSIX extensions. It only has partial support right now. That'll allow us to have a two server comparison point when we see something controversial. But we do have some tedious work. We have to go through every single xfstest skip, and these are not always easy to read, because xfstest is not about writing perfect test cases. It's about sometimes taking somebody else's test case and hacking it up to run in an automated fashion. So some of these tests can be quite complicated to debug, but there are over 600 of them, and there are probably on the order of about 100 that we have to go through that we currently skip, that could be potential matches for features that are already in the POSIX extensions or that we can emulate, or things that we have to add support for. So one of the examples I wanted to mention was enabling special files. So enabling support. Last year we talked about how the POSIX extensions were changed to implement special files as reparse points to allow, in a way, the extensions to stay small, right? By having special files as reparse points, similar to what WSL does, that enabled us to keep the POSIX extensions small. The smaller the POSIX extensions, the easier they are to document, etc. So basically, our default is to store these special files as reparse points. That's great. That enabled, that alone, just that minor little change, enabled 5 additional tests, 5 additional XFS tests. We also have to continue extending the dissectors to make them easier to use, to make sure that they decode properly the info level, the POSIX query FS info and query info level, and to make sure that it's easy to debug applications and clients and servers that are using these POSIX extensions. We also need to continue to update the wiki. There's a wiki for this on samba.org, SMB3 Linux, and we need to keep that wiki up to date with the implementation, notes, how to use it. There's information there about the settings you want to make in SMB.conf. You can also look at some of the previous presentations that talk about the Samba server configuration settings. As I mentioned on the client, it's very easy. As long as you're mounting to a server that supports SMB3.1.1, you just use the defaults and add one mount option, POSIX, POSIX. So in addition, if you have comments or questions, the mailing list, Samba Technical for the server and Linux CIFS for the kernel client, copy one or both of those with questions about the POSIX extensions. If you find bugs, you can open them in bugzilla.samba.org or in the kernel Bugzilla. And we really look for your feedback on this, because no one person is aware of all the application workloads and requirements. We've made incredibly good progress this year. Thank you to some of the work Aurelien, Ronnie, and others have done. And I also want to thank some of the work Volker. Thank Volker for some of the work he did adding the support for the additional client. This is a very exciting time. As we support POSIX workloads, as we support Linux workloads better, this opens up the world. The smallest devices to the largest devices. This opens up the possibility for many improvements in how people access network storage. And this, I'm sitting in a hotel room today, and as I made a copy of this presentation, I was saving the presentation into the cloud. And whether that's in San Antonio or whether that's saving it in Dublin, it is incredibly helpful for things we do every day that these POSIX extensions work well, and that SMB works securely for all of the application requirements that people have, not just writing a presentation, presenting, saving. Now, this is something that needs a lot of help from you guys, though, so please keep up the communication with us, and we welcome patches, we welcome feedback on what could be done to improve these POSIX extensions and also improve the implementation. And I want to thank you for your time, and I hope you enjoy this conference and the presentations. And please, if you're involved in the test event that's going on with this, please feel free to experiment with these and communicate with us, and we can give you additional information on how to configure and set these up. Thank you.